Hello everyone, welcome to Learn Overflow. So in this video we'll be discussing about linear search and we'll discuss how linear search algorithm works. We'll show you it's working in a array and we'll see how this works. So to say about linear search, so linear search is basically a searching algorithm where we find the element within a list. So unlike binary search, linear search can be in linear search the array is not required to be in a sorted order. It can be in an unsorted order. So here you can see an example of where I took a unsorted array and we will work on this array to find out element in using the linear search method. So it basically sequentially checks each element of a list until it finds a match and or the whole list gets searched. So before we just deep dive into linear search, we should know a bit more about the searching algorithms. So searching algorithms, once we divide the searching algorithms on a general classification, we'll find that it can be divided into either sequential search or interval search. So as an example of interval search, I took binary search, and I'll put that video or binary search in the I button above. So in binary search, these algorithms basically designed for the sorting, for searching in a sorted data structure or the array when it's in a sorted order. But in sequential search, we traverse the whole array or the whole list in sequentially, that we check every element and then we figure out whether a search element is there or not. That's the exact way of doing this, both the techniques. So I have discussed interval search, that is binary search, in another video. In this video we'll talk about sequential search. Now let's say we have a search element 19 and it's given that we need to search whether this 19 is within the array or not. So how will this linear search work? So first we'll check whether it's in the first position, that there is array of 0th position, whether this is 19th or not. We see that 2 is less than 19, that is just not equal to 19. Then we'll move to the second position, that is 32, that is array of 1. So then we'll see whether it's equals to 19 or not. In the similar way, we'll check the third position. We'll check the fourth position. That is, we'll start checking one by one that whether the value at that position is equal to 19 or not. We'll go on to the fifth position, and ultimately, when we reach the sixth position, we find that the array is found at this position, right? So we'll say we'll return that this particular value, that a of 5 is 19, we found it. So we'll say yes, we found the search at position 5. Okay, so this is the way it works. In case say our search was 45, it's such a value that's not in the array, so it would go like, search the first position, search the second position, search the third position, then search the fourth, fifth, sixth. Ultimately, it will go to the seventh, it will go to the eighth one, and it will go to the end of array, ultimately finding out just nothing within the array. So it will just return us that the array element is not found. This is similar to what we do in our regular life. All right. So in linear search, if you just remember, if you're searching for your notebook in a pile of notebooks, so how you do? You just check the first notebook and see whether that notebook is yours or not. Then you move to the second one, then you move to the third one. Similarly, go through the whole pile of notebooks and figure out which one is your notebook, right? That's the process you find out, and the process of searching you follow in your regular life. But remember, the linear search is least used in computer or in programming, since it's of high complexity and it actually takes a longer time to search an element. We prefer using binary search or other searching algorithms to make a search operation in algorithm in algorithms. So let's see the program or the Python implementation of this linear search. This is a simple implementation. We just define a linear search function, and then we just pass in the array. the array we are searching for and a search element that we need to search. So in that we just run a for loop of for I that runs in the range of the total length of the array. So remember we need to pass here the total length of the array, that we need to traverse the whole array. That's why it becomes like in case the search element is not within the array, so the complexity becomes order of n. That's the worst case complexity becomes the order of n. Like we need to search the whole array, the n elements we need to check. All right. So what do we do? In the within the for loop, we just check if the array of this ith position is same as the query or not. In case it's equal, we just return the ith position. Else we return -1, denoting that we didn't find out a search. Moving on to the complexity, you may note that we need to search the whole array. So that's the reason why it becomes the order of n. The average complexity is also an order of n, but the best case complexity is order of 1. How when the best case complexity will arrive? The best case complexity can be seen if the item we are searching for is at the position 1, right? If it's at the position 1, then you can say that that's the best case complexity of that linear search is achieved. All right. So just giving for more information is that the space complexity goes around order of 1. Since we are not creating any other additional space, the space of the array is what we need to as a uh, required element. Also, the worst case space complexity is also order of 1. This is the since we are going in an iterative manner, we cannot go in a recursive manner. So recursive implementation is not available for this. So that's all for this today's video. Hope I gave some information for you to learn from it. Make sure you subscribe to my channel, like the video, and comment down your thoughts or your queries related to linear search. Thank you guys for watching this video. Hope to see you soon in our next video.